Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue learning about pandas, and specifically we'll talk about nullable integers and nullable booleans in pandas. So pandas does have a pd.NA especially for integers, and we'll take a look at how it works. So let's get into Jupyter notebook and start coding. Today what we are going to do is, just to be on the same page, we are going to upgrade the pandas and numpy so that we are able to use this pd.NA that we are going to discuss in this video. So I suggest running these two commands in your Jupyter notebook, which is exclamation mark pip3 space install space dash dash upgrade space pandas, and similarly this is for the numpy. Once you have this I've already installed it, so I'm not going to run these two commands again. Once that is installed successfully on your computer, then you can go ahead and import the libraries numpy and pandas that we usually do. So I'm going to import those, and after that you can check the version of pandas and numpy that you have on your computer. And to do that, you'll have to type this command where the pd dot, and there are two underscores here. So underscore underscore and then version and then again underscore underscore. So when you run this, these are the two latest pandas and numpy libraries that are installed on my computer right now. I upgraded it in the morning. So for this video we do not have a specific set of data, and we are going to create series as we go along, because the creating of the series part is important to discuss as well. So the first point we are going to look at is what is the integer type in pandas. So what is int64? And in pandas, if you notice, in numpy we had the int which is small n. So if you type np.array, and here if we say 1 2 3, now if you look at the dtype for this one, or if we run this, let's say dtype, we can see that this is int64. Okay, int with a small I. However, in pandas also has an array function. So if you type pd.array, and here if you type 1 2 3 and dtype, now this is int64 data type. Okay, so it's important to remember that int with a capital I, and we are going to use this particular int64 from pandas and not this int64 that is from numpy in most of the cases. So I'll explain that as we go on. So let's go ahead and create a series, an array, a pandas array. I know that's a new concept. You've been learning about numpy arrays. Now this is a pandas array. So you'll get used to it by the end of this video. So here let's go ahead and create an array A, which is pd.array, and here in open close parentheses and open close square brackets we specify the numbers. So I'm going to type 1, none, and 3. And the reason why I've put none there is to show you how the int64 data type looks in the output. So when we look at the dtype, we are going to specify that this is pd.int64 dtype. Okay, now when we run this for A, here as you can see, as opposed to pandas, as opposed to numpy, here the none is replaced by NA within these angled brackets. Okay, we used normal numpy array. So for example, np array 1, none, and 3. In that case, as we can see, it stays as none, but then the data type that is created here is an object data type. Okay. Next, when we create this array, we do not have to use this longer function here. We can there is a shortcut we can use. So let's go ahead and copy that line of code and paste it here. Instead of typing this, we can simply say int64, and that is good enough. So when we run this, we get the same output as we got before, which is an integer array, and this is a pandas array where the integer which is missing is now stated by NA within angled brackets. Okay. Let's look at other types of missing items that this int64 can handle using pandas array. So if we have another array where we have this 1, this 2, and then we have np.nan, none, and pd.NA. Okay, and again we can go ahead and specify that the data type is int64 with a capital I. When we run this and look at the output, we can see that in this case, when this is a pandas int64, it notices that this is an integer data type, and therefore the missing values in that particular array are automatically converted to NA as opposed to NANs that would have been in case of NumPy or none. So that's the advantage of using int64 and pandas array. But while using the pd.NA, one has to be careful because it works in a slightly different way in some circumstances. We won't be discussing that in this video, but that's just to give you a heads up on that's a possibility. Next, let's look at how we can create a series using a pandas array. And does that NA or get transferred when we create a series out of an array? So the series that we have is this. Now if we go ahead and create that's the array we have, and if we create a series B which is using the series A, which is like this, and then we look for B, we can see that the data type still is int64, and we have preserved the NA in the particular array that we had earlier. So we still have the 3 NAs in the output of the Pandas series. Okay, we can also explicitly specify the data type as int64 while creating a series. So let's go ahead and create another series B, pd.Series, and we give it numbers 1, maybe none, and 3. Now data type, we can specify it as int64 with a capital I, and when we look at B, we can see that the output is int64 data type, and we do have the NA in place of none in the final output of the Pandas series. Next, let's look at how we can do operations on a series that has NA in it. Okay, so operations, and I'm going to create a few more cells here. Okay, let's go ahead and create a series Q, pd.Series, and we'll use the same 1, none, 3, and then we have the data type as int64. Okay, so we have the series. Now if we say we want to add 1 to the series, so Q plus 1, so I'm going to print the Q just so that we can see the data. Okay, so we were able to add 1 to the series, and the NA stays as NA because we cannot add the 1 to that particular value. So the NA does get transferred into the output after the operation is complete. That's the point to remember. Then if we look at Boolean, so if we say Q is equal to 1, in the output again we see that the NA does get transferred as NA, and the data type, of course, it's Boolean because we have true false in the output. Next, let's look at slicing. So if we slice this particular series right here, so if we say we just take the first 2 items, so that's index 0 and index 1, so we go from 0 to 2, and here we can see that again, even after slicing the particular series, we do get the NS in the output, and the data type still stays as int64. We could also go ahead and try adding, so if we say q plus q dot ilog, so here we could have specified ilog and we would have gotten the same result. So I'm going to use ilog here, and again if we have 0 to 2, and now here if we know that the q that we have has int64, but now let's say we go ahead and change the data type of this one to int8, capital int 8, and run this. In the output we can see that the int64 is still preserved, and we were able to perform the operations between 2 different integer data types, which is int64 and int8, again with a capital I here. Okay. Next, let's see if we can force that integer column or integer series to change to a float. So q, if we add a float value to this, now we see that the data type has changed to float 64 because we have added a decimal number to the series q, which was earlier integer. So that would be one way where you can force that integer data type to change to float. Next, let's see how the NA works in DataFrame. Here we'll create a new data frame, df pd.DataFrame, and we are going to create 3 columns. Let's say A is equal to, here we'll use the same series q that we have created above, and for column B, let's go ahead and add some numbers, 4 5 4, where there is 2 times 4 because we are going to do a group by later on, so just repeated those twice. And a column C with M, N, M, N, and O. When we look at the df, we see that we have 3 columns with NA there, and we can also go ahead and look at the dtypes, and we can see that the column A is int64 with a capital I, that's pandas integer, and then for column B we have int64 which is small I, and then column C is object. Okay, now here if we take the column A, so let's say if we take the column A and if we want to convert it to float, can we do it? So as type float, and we can see that we can convert the NA to float, and once we convert it to float, now the NA is changed to NaN because that is representative of a missing value in floats. Okay, so what we discussed here is we were able to use a series with integer 64 to create a data frame, and see that we can also convert it back into a float column. Moreover, we can do other mathematical operations on this. So if we say df.sum, we can add these. So also integer numbers are added, so 1 plus 3 4, and then we have the b column added, and the MNO is just object column that has concatenated here. Finally, let's look at how we can do a group by. I'm going to create new cells here. So df, this is the data frame we have, and if we go ahead and group by on column B, so that we collect 4 together and then 5 as separately, let's see what answer we get. So we group by on column B, and we want to use the column A as values, and we are going to sum the values in column A based on the groupings in column B. So here we can see that for the value of 4 in column B, we were able to add these values in column A. So 3 plus 1, that's 4, and that's what we get here. However, for the value of 5 in column B, we have a corresponding NA in column A, and therefore that value is now changed to 0 after the group by. It's not NA, it's converted to 0, and the output data type still continues to be int64 with a capital I. Okay. Next, let's look at a couple more examples using series and how that would work if we were to concatenate Concat Series. So that's what we are going to do now. Series A1 is a pd.Series series, and here I'm going to create 1, none, and then we have pd.NA, np.nan, and then data type is int64. So that's our first series. I'm going to copy this and repeat it 2 times, and then we have the series 2 A2, and then we have series A3. The difference is that here I'm going to remove the int64, and for this I'm going to change this to a character column, and again remove the int64. So that's our series we have. So if we look at A1, we see that it's a int64. If we look at A2, it's an object. Because of these missing values, it's converted to object. And if you look at A3, it's again an object series. Now if we go ahead and concatenate this, so pd.concat, and here we provide the list A1, A2, A3, and then access is equal to 1. This is the output. So why don't we go ahead and save this? Let's say df2 df, and we can go ahead and print df2.dtypes and df2. So as you can see, the series, which was the first one, A1, does remain as a int64, and the other two continue to remain as objects. Okay, so that was the take-home message there. Now let's look at how slicing would work again when you're using the arrays that have int64. Series. So if we look at the series A, that it's changed. So okay, it doesn't matter. So this is good enough. So this is the series that we have, and I was wondering if we could put, and so in here at index 0, 1, 2, we can go ahead and put a none, and it'll get converted to NA. Okay, so what we can do here is, if we pull the value at, let's say, A2, we can see that it comes as NA, and the reason is because it is the data type is specified as int64. Now here, if we had a series, let's say A is equal to pd.array and 1 none 2, and we specified dtype is equal to int64 with a capital I. Now here, if we pull the value at A1, we still will get an NA. So that's just to show that the NA is retained in the output if there is a missing value in a pandas array that has a data type of int64. Next, let's look at a couple of Boolean comparisons using AND and OR. So we are going to look at AND, and we are going to look at OR with a pipe. Okay, this has to be M. Okay, so pd.Series, and here if we specify a list in here, true, false, np.nan, dtype is equal to object, and if you look at the Boolean operation between these two, or true. So what we know for sure is true or true is going to be true, false and true would be true. However, what happens with nan and true when the data type is object? So if the data type is object, the nan and true comparison, nan or true comparison results in false. Now if you copy this and change the data type to Boolean, everything else stays the same. In this case, the nan and or true comparison results a true in output. Okay, and the reason why in this case this is true is because nan could have a value of either true or false. So if it is true, then true or true would be true, and if it were false, then false or true would again be true. And therefore, when the data type is Boolean, regardless of what value here is, even if it's nan, and if in the OR if you have a true, then the output would be true. Next, I'm going to copy this entire series. Let's look at how AND works. So if we first use the data type object and try AND, so here we know that true and true is true, false and true would be false. Now what happens if we have nan and true? So again, nan and true is false when the object data type is object, and here if we change that to Boolean and still have and true, here we see that the output now is NA. Okay, and if you think about it, this makes sense, because if the np.nan here, if it were true, then true and true would be true in the output. However, if the np.nan was false, then false and true would have been false. So there are two possibilities that can take place when there is np.nan or a missing value and true in a condition. Therefore the output is kind of undecided, and hence it's nan. That was it for this video. I hope you all learned how to work with pandas NA, pandas arrays, and incorporate them in series and data frames. how to handle how to handle missing values, like especially integers, using Pandas Int64. In next video, we'll start a new topic and look at visualizations using Pandas, and that's going to be really exciting. I look forward to those videos as well. Please like, share, subscribe. It helps me stay motivated, and that's how I know that you really like the videos and you like the content. So it kind of guides me that I'm heading in the right direction also. Thank you, and I'll see you all in the next video.